There's a big problem the wind industry doesn't like to talk about. The blades on a wind turbine, the part that actually catches the wind, can't be recycled. They're a composite of fiberglass and resin that can't be melted down, so when they wear out, they get buried whole. And the United States alone is on track to landfill 2.2 million tons of them by 2050. But one man is looking to change all that. In a workshop in France, an engineer named Fabien Brun built a turbine that throws nothing away. It's made of aluminum tubes and the kind of plastic tarp that covers a truck bed. No carbon fiber, fiberglass, or concrete is required. Constructing this machine is extremely simple and cheap. It's designed to be staked into the ground by hand in an afternoon and be producing energy that very same day. The team behind it are touting it as the solution to demonetizing wind power by making it cheap and available for anyone and everyone who wants it. So is this really the solution for the future of wind? Let's find out. Wind power is a powerful tool in the fight for renewable energy, but it comes with its fair share of problems. Small-scale wind, in comparison to solar, is extremely expensive because high-quality components, braking mechanisms, and magnets are required to withstand constant spinning in severe weather at high speeds. The price relative to their energy output pales in comparison against a domestic solar array. Even then, that doesn't account for all the barriers you'll run into before even putting one up. A conventional turbine wants a concrete foundation poured days ahead, a crane to raise the tower, and a trained crew to wire it, which is a serious build before you make a single watt. Even at the utility scale, wind isn't exactly a trouble-free solution. A big turbine blade is a single molded piece of glass fiber reinforced plastic, sometimes 150 feet long, bonded together with a thermoset resin. And that is a problem, because once these things are built, they can't be recycled. There's no melting them down and reusing them like we do with steel beams or aluminum cans. So when a wind farm swaps its blades after 20 years, those old ones mostly go one of two places. Option one is that they get buried in a landfill, sometimes sawn into 3 pieces, just to fit. Option two is it gets burned in a high temperature kiln, which costs energy and releases toxic fumes. Neither is clean and neither is cheap. And the scale of this problem is climbing fast. The National Renewable Energy Laboratory estimates the US will pile up 2.2 million tons of buried blade material by 2050. Worldwide, the running total over the next few decades reaches 43 million metric tons. Now, there are a few ways to recover some of the fiberglass back. A chemical bath under heat and pressure can recover more than 90% of the glass with most of its strength intact, and a controlled high heat process called pyrolysis can pull the fibers out too, though it leaves them weaker. But both are expensive, both aren't exactly environmentally friendly, and neither is operating at anything close to the scale the problem needs. So French engineer Fabien Brun set out to reinvent the turbine. He wanted to create a machine that wasn't just more sustainable, but more accessible too. One that didn't require civil engineers to prepare a site, specialist and expensive production, and a modular system that would allow anyone to build in the same way we assemble flat pack furniture. Not only would this make wind power more accessible to the domestic market, but also something you could ship to an off-grid community in Africa or India, a remote farm, or a disaster zone, and have running the same day. So the frame is made from standard aluminum tube, the kind sold by the length anywhere in the world, bolted together into a modular cube. The sails that catch the wind aren't sculpted blades at all, but panels of heavy plastic tarp, the same weatherproof sheeting that covers a truck bed or a market stall. The assembly is the other half of the idea. A conventional turbine needs a concrete foundation poured days ahead, a crane to raise the tower, and a trained crew to wire it. Brun's frame is self-supporting and light, so instead of concrete, it's pinned to the ground with steel stakes driven straight into the soil. You can carry it in flat pieces, put it together by hand, and stake it down without a single piece of heavy machinery. When you want it gone, you pull the stakes and the ground is untouched. Because the sails work mostly by catching the push of the wind rather than slicing through it like a precise aircraft wing, the machine doesn't need to be aimed. Wind from any direction pushes the panels and turns the frame. That's what lets Brun scale it like building blocks. A small one for a cabin, a stack of larger frames for a farm, each size feeding a charge controller that turns the spin into usable power for a battery bank. It's a clever reframing of the traditional turbine, and on paper, the economics look pretty promising. The price of a kit could start as low as 1,000 euros for the 0.3 kilowatt model, and as high as 10,000 for the larger 20 kilowatt model. The team estimates that the machine pays for itself in 5 years and saves its owner roughly $11,000 across a 25-year life. And at first glance, those numbers sound promising, although the reality of that might be a little different. You see, one of the main reasons wind struggles to be an efficient solution for off-grid power is due to the limited potential it has at a small scale. Wind's potential energy rises with the cube of the wind speed. So if you double the wind speed, you don't get twice the power, you get 8 times the power. But the numbers go the opposite way too. If the wind drops by half, you don't lose half your output, you lose almost 90% of it. So a turbine lives or dies on getting fast, steady wind, and near the ground, that's extremely hard to find. The Department of Energy estimates that if you put a standard 5 kilowatt turbine on a 35-foot tower in a decent wind area, it will make about 1,200 kilowatt hours a year. But take the exact same turbine and raise it to 115 feet at the same spot, and it makes 9,000 kilowatt hours. So just by climbing out of the rough air near the ground, the output jumps nearly 8-fold. So the height isn't a luxury, it's the whole game. And this is where Brun's design may potentially have a problem. The thing that makes wind to watt so easy to put up, that it stakes into the ground with no tower and no crane, is the same thing that pins it down in the slow, turbulent air, where wind power barely works. Independent field studies of roof height and ground height microturbines have measured them running at load factors under 3%, a sliver of what the brochure math assumes. On top of the concerns over real-world performance, there's also the question of the commercial incentive. Despite being a product that places itself as the solution to making wind energy accessible to all, this is not an open source solution, and instead the design is a proprietary one, with the patent held by the company, with published targets of achieving annual revenue north of 1.5 million euros within the coming year. If the real aim were to get cheap wind into the hands of off-grid communities as fast as possible, the quickest route would be to publish the plans and let anyone, anywhere, build one from local materials. So there's still plenty of question marks surrounding all of this, but wind to watt is still early in the development phase and is expected to begin pilot trials next year. But if it wants to be a serious contender as a solution to grid independence, then those trials have to prove that it can generate enough energy to reduce the unit cost of electricity for everyone that proposes to use it in the future. So back to the question in the title. If a cheap, recyclable turbine exists, why is the energy world so quiet about it? The answer isn't that anyone's holding it back. It's a stack of plain, boring reasons, and the first one is the law. Across the US, roughly 25,000 local zoning offices cap the height of a backyard structure, very often at 35 feet. Most of those limits got written in the 1800s, so a fire crew could hose down a roof, and nobody has rewritten them for wind. But 35 feet is exactly the height where, as we just saw, a turbine drowns in slow air. To put one up where it would actually work, you need a variance, which means public hearings, an engineering review, and a visual impact study, with no guarantee you get a yes. Then there's certification. To qualify for the 30% federal tax credit that makes most home renewables pencil out, a small turbine has to pass standardized independent testing for safety, durability, and its real power curve. That testing runs $100,000 to $250,000 per model. A small workshop project priced at $1,000 a unit simply can't absorb that, so it stays off the incentive lists, which makes it cost more in practice than a subsidized rival. And that rival is the real reason. Over 20 years, solar panels got radically cheaper, and they have no moving parts, no nightly upkeep, no vibration, and an output you can predict from a map before you buy. Wind at a single house is the opposite. Local, gusty, mechanical, and only as good as that one spot's air, which you can't know without measuring it for the better part of a year. A solar quote takes an afternoon. A wind site takes a season of data, and a tall tower the zoning office may not even allow. Faced with that, homeowners and banks pick solar almost every time, and that's why home wind stayed a niche while solar went up on roofs everywhere. None of that is a plot against Brun. It's zoning, testing costs, and a cheaper rival. And those are the things any home turbine has to beat. So suppose you've got the one thing that makes any of this work. Real wind on real open land. Here's the straight path forward. Start by measuring, because you cannot eyeball wind. A data logging anemometer costs under $100. Mount it at the height you'd actually put a turbine and leave it for 6 to 12 months. If your average annual wind comes in under about 9 miles an hour, stop here, because no turbine, recyclable or not, will pay you back, and you've spent $100 instead of thousands learning that. There's also a sighting rule worth knowing before you spend anything. The base of the blades should sit at least 30 feet above anything within 500 feet of it. Every tree, roof, and fence. On most lots, that math alone forces a tower of 80 to 120 feet, which is the part the no tower designs quietly give up. As for the machines themselves, be clear-eyed about what's buyable. Wind to Watt is still in development and looking for funding, so it isn't a product you can order and stake in your yard today, and its real-world numbers haven't been independently tested. If you want a proven owner-built path right now, the one with decades behind it is the Hugh Piggott design, an open plan for a turbine you build yourself from carved wooden blades and a hand-wound generator. The raw materials for the turbine head run a few $100s, though you still need a proper tall tower and the willingness to maintain it. If you'd rather buy a certified machine and have it stand for 20 years, that's a Bergy-class turbine on an engineered tower, and you're looking at $70,000 and up before the tax credit. Whatever you choose, the one rule that decides everything is the one nobody can sell you around. Height beats hardware. A modest turbine up where the wind is clean will beat a fancy one stuck in the turbulence near the ground every single time. Get it up into the fast air, or don't bother. Brun's turbine is a real answer to a real problem. The blade waste crisis is here now, and building a machine that's recyclable from day one is a smarter fix than trying to bury or burn the old ones. As an off-grid tool for a windy farm, a remote worksite, or a community the grid never reached, a cheap turbine you can carry in and stake down by hand has a real place. What it can't do is rewrite the wind. The reason home turbines stay rare isn't a silence anyone's enforcing. It's the slow, rough air near the ground and the cube law that punishes it. Solve your wind and your height first, and only then does the machine on top start to matter. If you got something out of this, a like and subscribe help more of these find their way to people. And if you want to see the other half of the off-grid puzzle, the one that works while the wind sleeps, take a look at our video on Pico Hydro next, a setup that runs a trickle of stream water through a $50 machine and quietly makes power 24 hours a day with no battery wall required.